Hi there. Okay, so what we're going to do is we're going to talk about Faraday's law of electrolysis. Okay, so when we do electrolysis, we are going to be using this formula. Okay, Q equals to IT. Q stands for, it says here, electrical charge. Okay, and it is measured in coulombs, electrical charge. So now let me explain this to you first. Apparently, an electron carries a negative charge. If you just have one electron, right, it carries a negative charge, and according to scientists, the charge has a value of 6.02 times 10 to the power of negative 19 coulombs. So if you take one electron and if you measure the charge on it, that's the unit. And if you take this number and you multiply this number with the Avogadro's constant, you get a number which is approximately 96500 coulombs. This number is called 1 Faraday. Okay, 1 Faraday. What is 1 Faraday? 1 Faraday, or this is the charge carried by 1 mole of electrons. Okay, charge carried by 1 mole of electrons. So when you have a circuit, let's say you have a circuit, right? When you have a circuit, okay, let's say this is a circuit now. Let's say this is a light bulb. Okay, so when you have a circuit, when electrons are moving through the circuit, okay, let's say 1 mole of electrons are moving through the circuit, 1 mole of electrons, we say 96,500 coulombs of electrical charge is going through the circuit. That's what it is. So to calculate the amount of charge which is going through a circuit, we use this formula, Q equals to IT, where A is the current, okay, amperes, time is in seconds. So for example, let's say if you're doing electrolysis, and let's say the current let's say the current is, let's say 3 amperes, okay, and the time that you're using is, let's say 12 minutes. So the electrical charge that is going through the system will be 3 times 12 times 60. So we are converting minutes to seconds. So the answer here would be 12 times 60 times 3. So you get 2160 coulombs. So which means that 2160 coulombs of charge is going through the circuit during that time. Then that brings us to this formula. Q, the charge, equals to the number of moles of electrons times with Faraday. Faraday was 96,000. So if I use this formula here, right, 2160 equals to number of moles of electrons, which I don't know, times 96,500. Then this will give me the number of moles of electrons. So the number of moles of electrons will be, okay, so this will be the number of moles of electrons, right? 0.0224 moles. This means that during this time, during this 12 minutes, 0.0224 moles of electrons was going through the circuit. Okay, 0.0224 moles of electrons was going through the circuit. So let's say if this was a circuit, so we can also say in that experiment just now, 0.0224 moles of electrons was going through the circuit. That's basically what it means. Yeah, that's basically what it means. So this will allow us to do simple calculations to find out about quantitative electrolysis. Okay, so let's say is there a question here that we can try? Okay, let's say this question here, right? Okay, let's say this question. The answer is already worked out, so we are just going to go through this with you. So let's say we have something like this. A nickel spoon is electroplated. The spoon is attached to the cathode. Okay, so whenever we do electrolysis and we want to plate one metal with another metal, it has to be the cathode. Okay, fine. How long the electroplating will take if 4.73 grams of silver to be plated and the current is 1.5 amperes? Well, first thing that we do is we find the moles of silver. So 4.73 divided with 107.9. 107.9 is the molar mass of silver, right? So 4.73 divided with 107.9. So this will give us 0.043 0.84 moles. This is the number of moles of silver which is deposited. Then we look at the SRP table. We find this equation, silver plus electrons, you get silver. So the relationship the relationship between electrons and silver is for every 1 mole of electrons you get 1 mole of silver. So which means that if you have 0.04384 moles of silver, you need 0.04384 moles of electrons. So we have that many moles of electrons, right? So then what we do is we use this formula just now, Q equals to number of moles of electrons times Faraday. So number of moles of electrons will be 0.04384 times 96500. So this will give you the charge, so times 96500. So now we know the charge was 4230.26 moles. Okay, sorry, what am I doing? Sorry, I made a mistake here, right? Sorry. So what I wanted to do here was, sorry, this was Q. Okay, this was Q, sorry. So this would be that many coulombs. All right, so now we know the coulombs. So what we do is we use this formula, Q equals to I times T. So we know Q is 4230.26. I was given to as 1.50 times T. So T will be 2820 seconds. So they want minutes. Okay, they want minutes. So what we're going to do is we're going to divide this with 60. So we get 47 minutes. Okay, let me just check significant numbers. 3 significant numbers, 3 significant numbers. So my answer is 3 significant numbers as well. Okay, so of course we check the working here. Yep, we got it correct, right? So that's basically how we do these type of questions, right? Then that brings us to this part on batteries. Now when we talk about batteries, I just want to very quickly go through this because it's not very important. We have primary cells. Primary cells are cells that cannot be recharged, like all your AA batteries, your AAA batteries, they cannot be recharged. Okay, you do not need to memorize any one of these reactions. You don't need to know how to do this, okay? But basically you just need to know they cannot be recharged. Then this is an example of that cell. You do not need to memorize anything here at all. Secondary cells, on the other hand, secondary cells are cells that can be recharged. Okay, cells that can be recharged. That means like your handphone. You use your handphone, and then after that what you can do is you can plug it in and then you can recharge your handphone. That's called secondary cells. So both primary cells and secondary cells, all of the chemicals that you need, right, they're already in the casing itself. Like you see your car battery, right, all the chemicals that you need are already in the car battery. So these are also called storage cells. Okay, storage cells means store. They already store all the chemicals that you need. So primary cells and secondary cells are also called storage cells. Okay, so these are the reactions that take place in your car battery. This is what happens at anode, and this is what happens at cathode. So let's look at this example here, right? Okay, let's look at this example here. So this is anode, and anode will be the negative terminal. This is cathode, positive terminal. Okay, so inside of this we have an electrolyte which is sulfuric acid. It's called sulfuric acid. So the anode, okay, it's already here but I'm just going to go through this with you. Okay, anode, which is the negative terminal, is made up of lead, right? The lead undergoes oxidation, right, to become lead ions. Okay, simple. But because it is soaked in sulfuric acid, what happens is these lead ions, they combine with the sulfates and form a precipitate which is called lead sulfate. Okay, so you get lead sulfate forming at anode. Meanwhile, at cathode, okay, so cathode is this one here. We have lead oxide, okay, lead 4 oxide. So lead 4 oxide is like Pb 4 plus and oxygen. So when you combine together, you get lead 4 oxide. Here what happens is lead 4 oxide undergoes a process called reduction. It becomes Pb2 plus. So from here it was oxidation, right? Pb becomes Pb2 plus, becomes this. So now if we balance the equation under acidic conditions, what we do is we add 2 water here, we add 4 hydrogens here, and we add 2 electrons to balance off the charge on both sides. Okay, so to balance off the charge on both sides, we add 2 electrons. All right. This is the half equation. This is the half equation that happens in your car battery when it's producing electricity. So if you connect this with let's say a light bulb, right? A light bulb, what will happen is electrons will come from here and then will go over there. This is the equation that happens when your car battery is producing electricity. Same thing on this side, right? Same thing on this side. Because you're producing lead ions, the lead ions can combine with the sulfates in the sulfuric acid to produce lead sulfate solid. Okay, now this is what happens when your car battery is producing electricity. But when your car battery goes dead, it dies, what we do is we do recharging. Just like your handphone we do recharging. So during recharge, basically what happens is very, very easy. We just reverse all of the reactions that have taken place. Okay, so like for example, let's say this was the reaction that took place here, no? So we reverse it, we just write it in reverse. That means Pb, so not clear. Sorry, it's not clear. So we say Pb 2 plus picks up 2 electrons and becomes Pb. See, we just reverse the equation. So instead of writing it this way, we write it this way, the other way. Here, instead of writing it this way, we write it this way. So Pb 2 plus picks up 2 waters becomes PbO plus 4H plus 2 electrons. So we just reverse everything. Okay, very easy. So this is during recharging. Okay, let me just erase this part off. Okay, so what the equation that I'm writing at the bottom here is during recharging. During recharging, we are doing the reverse of whatever has happened. But I want to ask you something. This process here is called reduction. Okay, reduction. Where does reduction happen? Reduction only happens at cathode. Okay, and this process that I've written here is called oxidation. Oxidation always happens at anode. So what we do is the polarity remains the same. Polarities remain the same. See, polarities remain the same. But what was cathode now becomes anode, and what was anode becomes cathode, because we are recharging. Okay, so whatever underwent reduction earlier now undergoes oxidation. Repeat, whatever underwent reduction will undergo oxidation. Whatever underwent oxidation will undergo reduction. So what was cathode becomes anode, what was anode becomes cathode, but the polarities remain the same. Now, last thing I want to tell you here. When your car battery is producing electricity, this part here, it is acting as a galvanic cell. That means it's producing electricity. But this part here, when you are recharging your car battery is acting like an electrolytic cell. Just like your phone. If your phone is not connected to a power source now, it is acting as a galvanic cell or electrochemical cell. It's producing electricity. The moment you connect it to a power source, it is now behaving like an electrolytic cell. All the chemicals that underwent oxidation are now undergoing reduction. All those chemicals that underwent reduction initially are now undergoing oxidation. Opposite happens. Okay, so you should be able to write these equations for these equations, or if you're given any other equation, reversible, you should be able to write it. Okay. Then we have one more here, fuel cells. So fuel cells I'll talk to you maybe in the next video.